Hello, ndikulandireni pamene tikupitiriza phunziro lathu la graphs of quadratic functions. Lero tili mu lesson 2 ndipo mu lesson 2 tiunikirana interpreting graphs of quadratic functions ndipo muli ndine Cicero Juma. Tikamakamba za interpreting graphs of quadratic functions, we all know that quadratic function has got this form: y is equal to ax squared plus b x plus c. From here we have a, we have b, we have c as constants. Okay, so our main emphasis will be making graphs of these quadratic functions. Now here we want to understand the interpretation that we may find from graphs which are of quadratic functions. So we will dwell much on the interpretation of graphs, in this case quadratic functions, and we will learn how to describe the effect of a, b, c, these constants. Okay, how do they affect maonekedwe a graph yathu, a quadratic function graph yathu. So we will also draw much on that one in this lesson. The other thing, we will try to look at maximum and minimum values of quadratic function when interpreting graphs of quadratic function. Then we will look at the equation of the line of symmetry. Okay, so in this lesson, in this topic, the other thing that we'll also dwell much on is to understand the equation of the line of symmetry. Okay, some of these we'll do them today, some of them we'll keep on doing as we move on with our lessons. Remember, we have y, that function, that's a quadratic function, and we have this a, b, c as our constants. Now let us look at this quadratic function, which is y is equal to ax squared. Y is equal to ax squared is a quadratic function. It's a quadratic function. Only that this b is equal to 0 and this c is equal to 0. So if these are 0, it means you have 0 there, which means it's the same as not to write anything. And if that is 0 as well, you can leave it without writing anything. So we have this type of graph. Now here we want to begin by looking at how the constant a affect this quadratic graph. That is, if you change the constant a. In this case, we have these three quadratic functions. We have this one, y is equal to x squared, and this one is equal to y is equal to 2x squared, and the last one, y is equal to 3x squared. In this scenario, we have a is equal to 1 for the first equation. For the second equation, a is equal to 2. For the second function, a is equal to 3. So you can see we have an a with different values. Now, in this lesson, we want to see this quadratic function. If we put it on a graph, how does it look? How do the change in the constant a affects our graph yard? So that is what we are about to do that. Now, before we plot a graph, remember we need to come up with a table of values. In this case, we need to come up with 3 table of values. We have function number 1, which is y is equal to x squared, and we can have this table of values. Then we have y is equal to x squared. We can also have is table of values. Then we have y is equal to 3x squared. We can as well have is table of values. Okay, so we can have our values. We can have any range. Last time we had a range of -4 to +4. In this case, maybe let's reduce. We can have from the range of maybe -3. Okay, that is the value of x, -3. Okay, and 3. Okay, so it could be from -3 up to 3. Okay, so let's do that. So we have -3, we have -2, we have -1, we have 0, we have 1, 2, and 3. So let me arrange this. X, this is y. We have -3, -2, -1, 0, 1, 2, 3. Okay, so we need now to just substitute panoply x kuti beze ma y values. How to find my table of values? I think it in now on lesson 1. You can go and check. Here I'll just put pano TNT jambule plane. That is an XY plane. So this is x and this is y axis. Okay, so we have my 2 demarcation. We have to count my 1. We have 2 there. 4, 6, 8, 10, 12, 14. Okay, now let's put up on the x-axis values. We can as well to I think a scale of 2. We jump to 2 demarcations will mean 1. So this is -1. There's 0. This is -2. This is -3. 1, 2, 3. I think it's 1 up to 3 x-axis. I mean it's 0 to 3. Okay, so let's start with this one. Okay, the first one, which is y is equal to x squared. In this case, we can start with here -3. It's equal to 9. So 2, 4, 8. 2, 4, 6, 8. 9, it's between 10 and 8, so it's there. And this is our 3, and here it's where they are meeting. This is where they are meeting. That is where they are meeting. -2. -4, 2, we have 4. So it's here. Okay, then -1, we have 1. We have 1, -1 x-axis. We have 1 y. So it's here. Sorry. And this is 0. 0, 0, 0 is there. Then when it's 1, it's 1. So it's here. When it's y, when it's 2, p number is 4, so 2, 4 is there. I'm meeting here. When it's 3, we have 9. So 3 is this one. This is where 9 is. So that's the meeting point. Okay, so now let us draw a curve. Now, this is our curve. So it's a sketch. Good. Because of it is no problem. Okay, so that's the first one. This one is y is equal to x squared. Maybe before we label them, let's see how other come out. Okay, maybe let's just say here y is equal to x squared. The second one, let's do this one. When it's minus 3, y is 18. So where there is 18, this is 18. So this is 18, that's minus 3. So let's go whenever. When it's minus 2, y is 8. And this is 8. This is where they're meeting. And when it's minus 1, y is 2. And this is 2. That is where they're meeting. And when it's 0, it's also 0. So it's the same there. When it's 1, it's 2. So it's here. 2 is there. When it's 3, when it's 2, it's 8. So this is where 8 is. So that is where 8 is. And when it's 3, it's 18. So this is where our 18 is. Okay, so let's draw a curve. So we follow those lines. Okay, follow them. Like that. Okay, so that's the second one. This one is y is equal to 2x squared. Okay, and let's now draw the last one. We're saying y is equal to 3x squared. So x is when x is minus 3, y is 27. So that's 26, 27, which means it's up there. So this is minus 3. So 27 has to be somewhere there. So if this is 26, 7, the other one 28. Okay, so 27 is here. When it's minus 2, y-axis is 12. So it's minus 2 here. This is where 12 is. And when minus 1, where's our 3? This is 2, and here is 3. And when it's 0, you are going to get 0 there. So when it's 1, we're going to get 3, and 3 is here. When it's 2, we're going to get 12. 12 is here. Twelve is here. When it's 3, let's get 27. I'm saying 27, 26, 24, 26, 27 is this line. Which means it's this line, it's here. Okay, so now Let us draw the points, connect the points to have our curve. So this is it. Out. Okay. So now this one is our y is equal to 3x squared. Okay, so basically we have these three graphs plotted on the same plane. Now by just plotting like that, you're able to see our graph inayamba yotambasuka. Now it's getting closer in and inner towards the y-axis line. Okay, so what have we noted from this? We all know that the line, let's say, what have we noted? Let's put here, noted. One, graphs zonse zikubwera pa 0 apa, zikakuchoka zoma zafikira pa 0 apa. Okay, and on that 0, it's what we call its line of symmetry. It's at x is equal to 0. Okay, so says the little zikuyamba kutembenuka pamene pa 0. So we can say that we observed kuti graphs have line of symmetry. Symmetry at x is equal to 0. At x is equal to 0, which means at x is equal to 0 is this one, which means this is this y line is our line of symmetry. Pamene kuyamba kutembenuka, that's what we call line of symmetry. Okay, and the number 2 observation, we also observed that as the value of a constant a decreases, the graph open. In other words, it becomes less steep. Okay, so we know that here a is 3, there a in this graph a is 2. Let me have the pointer. Okay, in this one a is y is equal to 3x squared, which means our a is 3. On this one our a is 2, on that one our a is 1. So what this second observation is saying is, as the value of a, which means that constant a, in this case we have 3, 2, 1, as that value decreases, here we are moving from 3 to 2 to 1, the graph open. Okay, so as it decreases, the graph opens up. You can see inali upper. Okay, inali upper, yachoka pamenepa yabwera upper. It's opening up. Moving away from y-axis. Yachoka pamenepo yadzabwera upper pamene pa 1. Apa is completely away from the y-axis, or from our symmetry, line of symmetry, which is this line, the line of y-axis, which is at x is equal to 0. And if you can see as well, because it's opening up, the steepness of your graph is reducing slowly by slowly. Okay, so basically, with this lesson, this is what we wanted to note. The coefficient a, the constant a in a quadratic function. In a quadratic function, how does it affect your graph? So we have seen here that the symmetry is always at x is equal to 0. If we put it in this setup, it has a symmetry. It has the line of symmetry, that is. And as the value of a decreases, the graph open up. Okay, So when this value decreases, okay, it opens up, or when the value increases, it closes up. It can close and it towards the y-axis line. Okay, so I think reaching this far, we now understand the effects that constant A brings to the quadratic function. Okay, quadratic function. Yeah, so reaching this far, let's meet again next week. Remember to like these lessons. You can share as well, just for us to reach out to as many students as possible. Okay, ata kukhalapo kuti pali ena amene akufunika thandizo ili koma chifukwa chonena kuti sakudziwa akusoma avutika, so help them to get access of these lessons. Thank you. See you in the next lesson.